Hello students. So these are some special types of integrals which we will be using for solving questions. Okay, you can note down this. This is a set 1 in which integral of the type 1 upon x square minus a square, or 1 upon a square minus x square, or 1 upon x square plus a square is given. Okay, in set 2 same integrals are there but with a root sign, 1 upon root. Okay, and for set 3 we have under root x square minus a square, so all these are in root sign. Okay, and the proof of this I have done in my videos. Okay, you can refer those videos for the proofs. Let's solve some problems based on this integrals. Okay, so this we will be using, this will be applied in solving some integrals. Let's solve this. So this is under root 4 minus 3x minus 2x square. Okay, this question can be asked for 2 marks or 3 marks. Okay, so this is of the form under root, that is we have set 3. Okay, that we have to use here. So we have to make it in such a way that it should be something like a square minus x square or x square minus a square. Now here this 2x square has a minus sign, so I am taking this minus sign outside. So this will be under root minus 1 2x square minus 3x plus 3x minus 4. Okay, dx. Now we have to make this x square, okay, 2x square as x square. So I am dividing by 2 and this is under root and multiplying by 2. Okay, so this root 2 we can take outside, which is a constant. So integral minus 1 to x square plus 3 by 2x minus 2 dx. Okay, now this is of the form a square plus 2ab plus b square. Okay, that we have to write in the form a plus b the whole square. So these two terms we can take, that is this becomes our a square. I'll write here a plus b the whole square is written as a square plus 2ab plus b square. Okay, so a square we have, that is x square, and 2ab is in the form 3 by 2x. Okay, now we have to find our b value. So I can compare this, 2ab equal to 3 by 2x. Okay, we know that a is our x, right, because a square we have written x square. So a is our x. Okay, now 2 we can take here, so we'll get b, that is 3 by 4. So this term you have to write as b square here. So root 2 integral root of minus 1 x square plus 3 by 2x, so plus 9 by 16, that is b square we have to write. Okay, we have to add and subtract, minus 9 by 16 minus 2 dx. Okay, so this term will be our a plus b the whole square. So we can write it as root of minus 1 to a plus b is our 3 by 4 the whole square, minus this you have to do, so minus 32 plus 9, so 41. Right, so it will be root 41 upon 16, so it will be 4, this square. Okay, now you can take this minus inside, so it will be here, it will be minus, and here it will be plus. So we have a square minus b square. So I'll write it again. a square minus x square, sorry. So we can use the third set of formulas. Okay, so this will be root 2. We can use directly the formula, applying formula a square minus x square. So x by 2, our x is x plus 3 by 4 upon 2 root of the whole thing okay, plus a square by 2. A is our 3 by 4. Oh no, a is our root 41 by 4 square and divide by 2. So here into 2. Sine inverse x is x plus 3 by 4 upon a is root 41 by 4 plus c. So this is the final answer. Okay, let's solve this. So in this they have given e raised to x under root 5 minus 4 e raised to x minus e raised to 2x. Now if you look at this term, you will find that this is of the type x square plus a 2ab plus b square, that type, right? So we have to just substitute here, that is e raised to x we can substitute as t. Okay, so its derivative is e raised to x dx dt. Okay, so substituting we'll get integral as e raised to x dx is dt integral 5 minus 4 t minus e raised to 2x means this is e raised to x into e raised to x. So t into t, which is t square. Okay, so same way here you have to apply that x square minus a square or a square minus x square, that in that form you have to write. So first I'll remove this minus sign, so we can take that minus sign common under root. Okay, so you'll get t square plus 4t minus 5. Okay, now we have to write it in the form a plus b the whole square. So we have here t square plus 4t, so our 2ab term is 4t. Okay, and we know a term a is t, so b will be 4 upon 2, which is 2. So b is 2. So we have to add and subtract 2 square. So writing t square plus 4t minus plus 2 square, which is 4, and minus 2 square, which is 4, and we have here minus 5. Okay, so we'll get this t square plus 4t plus 4. So writing it t plus 2 the whole square minus 9, and 9 we know that it is 3 square. So taking the minus sign inside, you will get root of 3 square minus t plus 2 the whole square. So for this you have to use a square minus x square formula. Okay, so 1 upon under root a square minus x square is sine inverse x by a, and here x is t plus 2, a is 3, and then you have to substitute whatever substitution we have done, that is t equal to e raised to x. So e raised to x plus 2 upon 3 plus c. Okay, let's solve this. So it is given sin x upon sin 3x. So here you have to use the trigonometric identity, okay, which is sine 3x is equal to 3 sine x minus 4 sine cube x dx. Okay, so taking sin x common from the denominator, you will get 3 minus 4 sine square x. Okay, so this is of the type 1 upon 3 minus 4 sine square x, and this type of integrals we have learned, that is you have to divide by cos square x. Okay, divide by cos square x, both numerator and denominator. So dividing by cos square x, in the numerator it will become 1 upon cos square x, which is sec square x. Okay, and in the denominator it will be 3 sec square x, okay, minus 4 tan square x dx. Okay, so this sec square x I can write it as 1 plus tan square x, which is again a trigonometric identity. Okay, so when you take this 3 inside, it will be 3 plus 3 tan square x minus 4 tan square x. So we know that this is 3 plus 3 tan square x minus 4 tan square x is minus tan square x, 1 tan square x, right? Okay, now you have to do substitution, that is if you take sec square x dx, that is sec square x as tan as t, so you will get sec square x as dt. So substituting tan x as t. Okay, so your dx will be sec square x dx equal to dt. Okay, so substituting you will get here dt upon 3 minus t square. Okay, so this is of the form a square minus x square. Okay, so directly you can apply that special type of integral. Okay, a square minus x square, so this will be 1 upon 2 into a you can write it as root 3 square, right? So this will be root 3 to a log a plus x upon a minus x plus c. Okay, then substituting our t, you will get root 3, t is tan x plus tan x upon root 3 minus tan x plus c. Okay, let's solve this. So integral tan theta upon 1 minus sine theta d theta is given. Okay, so we can remove this 1 minus sine theta from the denominator by multiplying 1 plus sine theta in both, that is in numerator and also in the denominator. Okay, so that it will be a single term. Okay, so now this will be integral tan theta, taking tan theta inside, plus tan theta into sine theta upon, this will be a minus b, a plus b, so a square minus b square, 1 square minus sine square theta, which is cos square theta. Okay, so this will be tan theta, so sine upon cos into this, so it will be tan theta into sec square theta d theta plus tan theta into sine theta upon cos square theta. So tan theta you can write sine upon cos, then sine upon cos So this will be sine square theta upon cos cube theta. Okay, so now can write this, you can solve. Okay, this I'll write it as integral 1 and this is integral 2. So this is direct, that is if you take t as tan theta, d theta will be sec square theta d theta. So I'll solve integral 1. So integral tan theta into sec square theta d theta. Okay, so I'll take t as tan theta and dt will be sec square theta d theta. Okay, so integral t dt, so you'll get integrating t square by 2 plus c. So you can write in place of t as tan square by 2 plus c. Okay, so first one is solved. Now for the second one I'll write it as integral sine square theta upon cos cube theta. So again if you take sine theta upon cos theta, then another is there, right? Sine theta upon cos theta, and one more is there, that is 1 upon cos theta. Okay, this we can write it as tan theta into tan theta into sec theta d theta. Okay, now we have to do substitution here. Okay, so if you substitute here the derivative term, if you take derivative of sec theta, okay, that is tan theta into sec theta. Okay, that we can use here, but here extra term, that is tan theta, is there. Let's write t equal to sec theta. Okay, so derivative will be sec theta into tan theta d theta. Okay, so problem for this term is solved. We have to just write this tan theta in terms of t. Okay, so our sec theta is t. We know that 1 plus tan square theta is sec square theta, correct? So tan square theta will be sec square theta minus 1. So tan theta is root of sec square theta minus 1. So when we substitute sec square theta as t, this term tan theta will be root of t square minus 1. Okay, so I'll write here tan theta as root of t square minus 1, and this term is our dt. Okay, so now you have to apply that special integrals under root x square minus a square. Okay, so this is x by 2, so t by 2 integral t square minus 1 plus a square minus a square by 2, a is 1 log x plus, so t plus root of t square minus 1, your root is not there, x plus root of x square minus a square plus c. Okay, so in place of t you can substitute, that is t we have taken sec theta, so sec theta upon 2 root of sec square theta minus 1 minus half log of sec theta plus root of sec square theta minus 1 plus c. Okay, and sec square theta minus 1 is tan theta. So we can write this as sec theta upon 2 into tan theta minus half log sec theta plus tan theta plus c. So this is the final answer. Okay.